this week's experiment involves a lot of calculations to determine wavelengths of light that are emitted during electron transitions of hydrogen. So just some basic definitions. Principal energy level, these are the main energy levels. Sometimes these are called shells. If you're looking at an electron configuration like this, something like that, the principal energy levels are these numbers in front there. So you need to know that the higher the number, the higher the energy. So if you had an energy diagram, energy level 1 is down here, and as you go up, these are higher and higher levels. So an electron transition is when an electron moves up to a higher level or when it drops to a lower level. A transition can occur in our spectrum tubes when electricity is passed through the gas. That energy can cause an electron to go up to a higher level and then it'll drop down. Electromagnetic radiation includes a lot of different types of energy that involve electric and magnetic fields. And so visible light, radio waves, UV light, microwaves, there's a whole spectrum. Photon is a packet of light energy. And so with light, we can consider or think about it as being a packet or a particle of light, or we can think of it in terms of being a wave. And it's really both. It's just two different ways of thinking about it. And then basic definitions of frequency and wavelength. Frequency is how fast it cycles, and wavelength is the distance between peaks in a wave. And you need to know that, of course, there's equations that relate, let's see, energy, Planck's constant, and frequency. And then for wavelength, this one, we'll be using those. And then, like I was saying, with transitions, with our spectrum tubes, hydrogen's electron starts here, but it can be excited up to any level, just depending, probably all different levels. And then when it drops, it can drop just one or it can drop all of them. I see that this is not to scale. And the reason that's important, well, you'll see on the notes, there's a lot bigger distance from, this is 1 to 2, then they get closer and closer together as you go up. And that's important because when you have a transition that drops to 1, it always has a lot of energy involved. Okay, so next you'll go on to do this calculation, next video.